What is damping in automotive shock absorbers? Imagine driving over a bumpy road and feeling every jolt, or gliding smoothly as the vehicle absorbs the uneven surface. That's where damping in shock absorbers comes into play. It's a key part of vehicle suspension systems that keeps your ride comfortable and your car stable. When your car hits a bump, the suspension springs compress and then rebound. Without damping, this movement would continue bouncing for a long time, making driving uncomfortable and unsafe. Damping controls this motion by resisting the spring's movement and converting that energy into heat. Shock absorbers, also called dampers, work by forcing hydraulic fluid through tiny openings inside the shock body. When the suspension moves, a piston inside the shock pushes the fluid through these small passages. This resistance slows down the compression and rebound of the suspension. The more resistance, the slower the suspension moves. This process turns the kinetic energy from the suspension's motion into heat, which then dissipates into the air. This prevents the vehicle from bouncing excessively and helps keep the tires in contact with the road. Damping affects two main movements: when the suspension compresses from a bump and when it rebounds back to normal. The damping rate can be adjusted to control how quickly these movements happen. Higher damping makes the suspension respond more slowly, giving a smoother ride and better control. Lower damping allows the suspension to move faster, which can make the ride feel stiffer and less stable. In vehicle dynamics, damping is vital for managing how the vehicle responds during braking, turning, or accelerating. It helps control the weight transfer and reduces body roll and pitch. Proper damping keeps the vehicle balanced and improves steering response. Modern shock absorbers often include features like pressurized nitrogen chambers to prevent cavitation, which is the formation of vapor bubbles that can reduce damping effectiveness. Some designs use twin-tube or monotube configurations with reservoirs to maintain consistent damping under different conditions. Damping also plays a big role in safety. It ensures that tires stay firmly on the road, providing better traction and braking. Without effective damping, a vehicle could bounce uncontrollably, lose grip, and become harder to control. From an engineering point of view, understanding damping helps in designing suspension systems that strike the right balance between comfort and handling. It's a fundamental part of making sure your vehicle responds predictably and safely to all kinds of road conditions.